Hello student, today I will teach you the metallurgy of zinc. The main ore of the zinc, that is zinc blende, ZNS, and the next step, that is the concentration of ore. The ore is in the form of the sulfide, therefore it is concentrated by flotation method. After that, the step, that is the oxidation, that is done by the roasting process. This concentrated ore is roasted in air to convert it into the oxide form. And in this process, sulfur dioxide formed is used in the manufacture of sulfuric acid. And the next step, that is the conversion of the zinc oxide into their metallic form, zinc. The zinc oxide is mixed with coke and it is heated, where it reduced and formed zinc metal. In this reaction, the carbon monoxide formed, that is evolved and burns at the mouth of the retort. So being volatile at this temperature, the metal of zinc is distilled over and it is condensed. So that is the extraction of metal zinc from its ore, that is zinc blende. The next metallurgy is the metallurgy of the silver. The main ore of the silver, that is argentite, AgS, that is the ore of the silver. And the next step of the extraction of silver, that is the concentration. So it is concentrated by flotation method because it is sulfide ore. Next, the extraction by McArthur forest process. In this process, the silver ore, that is argentite Ag2S, is leached with a solution of sodium cyanide. Silver argentite, it is leached with sodium cyanide. So silver dissolves and form a complex, that is complex sodium argentocyanide. This complex is formed, sodium argentocyanide. Then this solution, it is further treated with scrap of zinc. The zinc displaces silver from this complex and it forms the silver. So silver can be extracted by this method, and the refining of the silver can be done by the electrolytic method. Next metallurgy is the aluminium. The ore of the aluminium is the bauxite ore, cryolite ore. Next step, that is the concentration. So that extraction mainly takes place in two steps. First stage, that is, it involves extraction of alumina from bauxite, that is purification of bauxite. And the second stage involves extraction of pure aluminum from alumina, and this is done by the electrolysis in molten cryolite. First stage, that is the purification of bauxite. So in the purification of bauxite, in the metallurgy of aluminium, the main impurities that are present: oxides of iron and SiO2 and titanium oxide, they are present as impurities. So impurities that are removed, and the bauxite that is first reacts with the NaOH solution. So this NaOH solution, when it is reacts with the NaOH solution, the alumina, it dissolves and forms sodium aluminate. This NaOH dissolves in the, this bauxite dissolves in NaOH and it forms the sodium aluminate, and it leaving behind the impurities, iron oxide and titanium oxide. Iron oxide and this titanium oxide, it leaves, and SiO2 silica, that also dissolves in sodium hydroxide, and it forms the soluble sodium silicate. So the impurities are filtered out, and this sodium aluminate reacts with water and it forms aluminum hydroxide. This aluminum hydroxide, on heating, it gives Al2O3. So in this process we obtain the alumina from bauxite. That is the flow chart. Impure bauxite treated with NaOH and filtered. The insoluble impurities, they separated out, and the soluble sodium metaluminate, it is heated with water, then filtered. So we obtain the precipitate of aluminum hydroxide. Again it is heated, then it forms the alumina. So that is the first step, that is the purification of bauxite. The reactions involved: Al2O3 reacts with NaOH, it forms sodium aluminate, and it reacts with water and it's formed the aluminum hydroxide. This aluminum hydroxide heated and it formed the pure Al2O3. The second step, that is the electrolysis of pure alumina. So electrolysis of pure alumina, in the metallurgy of aluminium, Al2O3, that is molten Al2O3, that is mixed with Na3AlF6 or calcium fluoride, cryolite or calcium fluoride. What is the main purpose of adding cryolite? Because it lowers the melting point of the mixture, and in this process, this steel vessel which is lined with the carbon, this acts as the cathode. It is cathode. Steel chamber, steel vessel and lined with the carbon act as cathode, and anode is the made up of the graphite. Here it is anode that is made up of the graphite. So the reaction which takes place, that the aluminum oxide, it forms aluminum and carbon dioxide. That is the overall reaction. And this process of electrolysis, that is also known as Hall-Héroult process. And this electrolysis process takes place in this electrolytic tank, that is electrolytic tank. So the oxygen which is liberated at the anode, it reacts with the carbon of the anode and it produces carbon monoxide and carbon dioxide. So the electrolytic reactions can be written as, at the cathode, the aluminum ion converts into aluminum. So at the cathode we obtain the aluminum. That is the outlet of the aluminum. Aluminum is deposited at the cathode. And at the anode, the carbon reacts with oxygen and it forms carbon monoxide. And this carbon monoxide is formed, and also carbon dioxide is formed. So that is, by this method we can obtain the pure aluminum. So this process is known as Hall-Héroult process. It is the purification of pure aluminum. And refining of aluminum. The metal which we obtain in the above process, that is about 99% pure, and for the most purposes it is taken as a pure metal. However, further purification of aluminum can be carried out by Hoops process. That is Hoops process. In this Hoops process, the cell that consists of iron tank, that is iron tank, consists of iron tank and that is lined with graphite at the bottom, and a molten alloy of the copper, gadolinium and silicon, it is used as a anode. That is impure aluminum act as the anode, which forms the lowest layer of the cell, and the uppermost layer, it contains molten aluminum, uppermost layer, and this middle layer that contains cryolite, mixture of cryolite and barium chloride. So in this reaction, in this cell, on passing current, aluminum ions from the electrolyte are discharged at cathode and pure aluminum collects at the topmost layer. Here aluminum is collected. And crud aluminum is added from time to time. Here it is crud aluminum. Crud aluminum is added and the pure aluminum is separated out from the top. So this is the refining of aluminum, and that is also called as Hoops process. So by this Hoops process, aluminum can be purified. There are some uses of aluminum. So aluminum is a very soft metal, and it has various uses. Aluminum, it forms many useful alloys such as duralium, magnesium, etc. And these are used in aircraft and other transportation vehicles due to its lighter density. And aluminum foil is used for wrapping cigarettes and confectionery, etc. And it is also used to produce metals such as chromium and manganese from their ore. That is aluminothermic process. And it is also used for making utensils, which are used for household purposes. So these are the various uses of aluminum. Due to its lighter density, it's having various uses. Aluminum. So in this topic, इन टॉपिक्स में आपने एल्यूमिनियम की मेटलर्जी, जिंक की मेटलर्जी और सिल्वर की मेटलर्जी आपने पढ़ी. जैसे सिल्वर की मेटलर्जी है, उसी तरह से गोल्ड की भी मेटलर्जी है. So the reactions of gold and silver metallurgy are very important, and the metallurgy of copper and आयरन एंड कॉपर, इन दोनों की मेटलर्जी आपने पढ़ी है पहले. तो all these metallurgies are important, and mainly the reactions which are involved in the metallurgical processes, these are very, very important. Thank you.